Sir? Hi, my name is Ved, and today we are going to talk about how to navigate through the spinning disc microscope. Before anybody comes for the training, I let them watch the 2 video tutorials. The first video tutorial is on the general overview of the software, and the second one is especially about the multidimensional acquisition, which we use for acquiring images. Now, with regards to the overall switching on the microscope, all the protocol is right here. Switches 1 till 8, everything is written right here, so anybody can come and do it by themselves. Usually the power strip here should always be on, that's switch number 1. Then the 2 power strips, 1, 2, then the CPU. Now while turning on the lasers, make sure to switch on the laser first, wait for it to turn blue, and then turn the key. If you do it, say suppose reverse, this will keep blinking like this. Or in the next one I will show what happens. If I turn the key too fast, again it will keep blinking. So make sure that you wait long enough so that it turns blue and then turn green. It will take about a minute to warm up. The lasers are solid state lasers, it will take about a minute. 561 laser has got some challenges. It overheats once in a while, so suddenly your imaging might stop. My software will be working fine, but it will be showing a fault, the yellow color light, so in that, or red color light. Then in that case, turn off the laser, let it cool down for a minute, and then turn it on again. Okay. Then this is the key for the spinning disc setup here. Why it is called spinning disc? Because there's a disc which spins at about 1000 RPM, and it scans the laser spots on the sample at a rapid pace. If you don't turn it on, all you'll be seeing is a few dots, that's it. Okay. Make sure you turn this on. This microscope can do super resolution also, and for that there is a magnifier here, which we put it out of the light path normally, basically pulled it out. But if it is pushed in, then there will be a 3.2x magnification lens also in light path. For routine imaging is never required, that's why I removed this, but you can always screw it in and move it back and forth. Okay, now moving on, this is the display unit, which is the microcomputer. While turning on, there's a power button on the top right hand side corner. While turning off, don't just hard shut it down, there is a off button here, and then you turn it off. We'll be talking about that towards the end. And that's the typical login, like your net ID and password. And typically everything should function properly. In case any issue happens, always restart the computer and the entire system. That fixes 90 to 95% of the issues. Now, if you just restart the computer directly, then it may log you off from your reservation. So the way to restart will be to click this icon, restart computer. This one will restart the computer without restarting your. It should ideally lead to a pop-up window here. In this case it is not working, then you have to contact the IT guys and they will fix this thing. What that function does, it restarts the computer without shutting off or cutting off your reservation. In case if this is not working, like in this case, which is reality a lot of times, in that case restart the computer, hard restart normal, but go and reserve your equipment again, because if the reservation is gone, somebody else will come and reserve it. Okay, that's it. Alright, now to start the software, here's the MetaMod software which we start. And while we are doing that, for the slide loading, we hold it here and push it up so that you can access the area. We have multiple holders here. This is the universal holder. You can also have a plate holder which is in the other room. In case you don't find something here, it could be in the other room, so always look around or ask around. There are 6 magnifications here. Only the 100x is an oil objective, others are not. So do not ever use oil on the other objectives, even though it is 40x magnification is here, like this case. It is not oil objective, it is air objective. People do put oil on this and it becomes a problem, and then we have to remove the objective and then use ethanol to clean everything. Okay. While placing this slide holder, make sure that it sits properly flat. Some people just leave it like this and they wonder why the sample is not fully in focus. So make sure it is fully flat, and while placing the slide, the cover slip should be facing down. Some people do the mistakes of doing it upside down. I have done that, and then because the working distance for this guy is pretty thin, so it will not be able to focus. Okay, so we'll expand this as much as possible, move it around. Before placing, I'm using right now the 100x, so that's why I'm using the silicone oil. I'll place 2 drops of oil on this. 1, 2. If you are reusing the same objective which already had oil, then use just 1 drop, that's enough. While placing the slide, if you are a new user, I would suggest that you leave a little bit of room so that that slide can move up and down, because there's a chance that you might hit the sample with the objective. Nothing will happen to the objective, but your cover slip might break. So this way, if any chance the objective moves up, then this can move up along with it. Okay, so we'll leave it like this. The control is here. This and should show the arrow, like if you turn it like this, it is going to bring the objective up. Okay, so if I start bringing this like this, you will see that the objective is going to touch the sample very soon, ideally, and it touches, and you will see it forms a nice thin film here of oil. That means it is in the right place. The typical diameter of this oil should be around 1 centimeter. That is when it is most focused. And if you look at the number here in the Z, it will be around 1500 micrometer. That's the area in which it is usually focused. You can always do it, play around with that, and then see when it is focused. Now, given the fact that there is no umbrella up here, so you might have to turn all the room lights to acquire good images, because this room light might interfere. But if you are able to see that there is no difference because of this room light, you can keep the room lights on. Okay. Now, with regards to the interface here, the magnifications can be found here. You will see that there are 2 20x's. One 20x is here, another 20x is here. One of them has got a correction collar, and the correction collar can be adjusted using this knob. Correction collar is specifically used for samples when it is not a cover slip. If it is a plastic bottom dish, for example, the thickness of that is different and the refractive index is different, so you might have to use that for correcting for the refractive index and the thickness. But in usual case, normal air objective 20x should be good enough. Try both objectives, see whatever works better, and use it. In case you are not getting clear images on the in the computer here, probably it's because the lens is dirty. So use some kind of a cleaner like this, and this tissue, not the Kim wipes, for cleaning the lens, because Kim wipe has got dust particles. Dust particles hardness is the same as that of glass, so we want to avoid that. So for now, we'll use 100x. Okay, and you should just stay near the sample, and it is okay. And as I change the objective, if you see the number rose to 3300, and it pushed the lens up, and then the slide is floating up. So that is why I kept it in a good place, so that it doesn't push it hard. I will bring it back to 1500, and that error can be fixed in the software. Whatever happened just now, that it pushed the sample too high, that was because the set parameter for that is too high, so we can change that later on, or we can contact Olympus to do so. Now we'll go to multi-dimensional acquisition here. All the laser controllers are here. If you see that the laser power is not enough, you can always change the numbers here. Okay. We'll start with this. There are multiple options that one can do. These are pretty intuitive. Like if you're going to do time lapse, you check this option. It will give you an option. Okay, I want to do 400 time points at a time interval of 0.4 seconds. So total duration will be multiplication factor of the two. And it says that minimum time interval should be 0.2 seconds. Why? Because it will take this image and this image, and total will be 0.2 seconds, and hence anything shorter than this, if you put here, for example, if I say if I put this, it will highlight and say that, oh, this cannot be possible. So I will just do whatever I can at this speed. So always make sure that this number is a little larger than this, or you play around with the parameters here so that always this number is greater than this number. For today we will not be doing time lapse, but this is how we do it. I'll check it off. For doing Z series, most people's sample have at least 2 colors, so doing multiple wavelengths will be useful. Multiple stage positions could also be useful when you have a live sample and you don't want to waste the sample, you want to capture multiple areas and then capture enough images, so you can always activate that. If you activate that, then as you can see, everything starts adding up. If I have 3 positions and if each image takes 3 seconds, then you have to have a time gap of 9 seconds total. So accordingly we have to make decisions, what do we really want. Stream is useful when you are trying to video record the things, and run journals, nobody ever uses that. Hardware focus, most of the times keep it off. In case something happens, it gets corrupted, you can always go here, load state, by clicking load, and you can select the one which you are using. In this case, spinning disk only. This one is super resolution one. Rarely we might use, but for most cases spinning disk only is good enough. Okay. Alright, so in my sample, before I start saving, you want to make sure that it is being saved in the right location. For today's thing, I will just put it on to some place like Ved Prakash here, and I'll put a new folder. The way I did the folders is year first, then the month, and then the date. Why? So that everything is organized. Okay? And then I put the folder name. This way, even if the folder is copied or moved, the order in which everything is arranged doesn't change. And make sure to put some file name, like I will call this as kidney because it's a kidney tissue. And if your file name has some number like kidney 1, make sure to have this increment file base name, and also after this number put some special character. Why? Because if this box is checked and you keep on acquiring image after image, kidney 1 will become kidney 2, 3, 4, 5. We don't want to change the overall name, so we'll put a hyphen, and then it will become kidney 1-1, 1-2, and so on and so forth. Okay? And if you don't check this box, if you just keep acquiring, it will keep overwriting the same file. So make sure that this box is always checked. Okay? Now with regards to wavelength, in my sample there are 3 colors plus bright field image. Okay, so I will choose 4 colors. 1, 2, 3, 4. Now which color should be image first? That will be very similar to that of spectrophotometry, that we try to image the longest wavelength first and then the shorter wavelengths. So in this case my sample has got 561, 488 and 405. So I will choose 561, SD 561. Then I will choose SD 488, SD 405, and this one I will be choosing as DIC bypass. DIC stands for differential interference contrast, basically a kind of imaging, so that you can get a good contrast of image. And bypass, why? Because I don't want the spinning disk to block unnecessary light to the camera. I just want simple light coming to the sample. Okay. So that way I can get a nice bright field image. Now to visualize, all we have to do is to change it temporarily to, say, suppose DIC eyes, and then click live. Ideally it should be no signal here, all the signal should be going to the eyepiece because of the setup that I did. Okay. And let's see if the sample is visible. And the sample is already kind of focused because I kept it around 1500, 1600. Okay. And if I go here and change this to DIC bypass, now it will send the light to the camera and I can see my object here. Okay. Now the lighting may not be sufficient. As you can see, it's a very low signal, it's 12-bit image, so even at 500 millisecond I'm getting less exposure. So you might have to make sure that the configuration settings are good. So here there's an option for configure illumination, and I will go and check if my intensity of the light that is being produced is good enough. So if I increase this, then my signal will improve, and now I can actually, it is 16-bit image now, and actually I can ramp it up all the way up and say add replace, yes, okay. And then I will go and reduce the exposure time so that I can get faster images. And now I can move around and I can get pretty good images. And I will turn off the room light. You see some of the particles are not moving here. This is basically dust particles in the light path, so you cannot do much about it. So that's my sample. Okay. Now I will go to, say, suppose spinning disk. Okay. So this is my signal, and this is at 50 milliseconds. So I might have to increase the exposure because this is a very low signal. I can see now some good area. Same way at 488. This is again very low. So most likely the laser is pretty weak. Still it is very weak. That means something needs to change. Okay, I will get back there. This is OK signal, 12-bit image. And I will increase the laser percentage to some good number. Right. So as you can see, I can go layer by layer and capture images one by one. And I begin my imaging somewhere here. When there is no sample, go to other side and capture until here. This is how I decide my Z stacks. Okay. Alright, so I will replace. Usually the users don't interfere with this one if it is set up properly, but sometimes the settings are not right, so we have to always change it. And if you see, earlier it was not working right. Now suddenly it is so bright. So some weird bug is there in the software that it likes to go to SD-405 and then everything looks fine. If I go here, now it should also be pretty bright. Yeah. It looks nice now. So if at all the intensity is not looking good, change this to SD-405, let it run and then go back here and it should be fine. Okay. Now if you want to capture the Z stacks for a particular channel, you can keep the Z series on with this wavelength, same way for this guy, and so on and so forth. The histogram here shows what is the intensity of these pixels. This is a 16-bit image, that's the max it can go. So it's a pretty bright image. If I increase this to further like 200, or let's say suppose let me do 500, you'll see that this is kind of saturating, it's too much signal. Make sure that this never reaches till here. Say suppose if I do 20 milliseconds for now. Yeah, image wise it's not looking very, still looking bright enough, but actually the image is pretty dim. If I go here, instead of doing whole range, I will do 16-bit range, and instead of doing auto scale, I will turn off the auto scale. You see this is the entire range in which the image can be built. It is actually auto scaled to this intensity. The actual intensity of this image is like this. So make sure that if you're trying to compare between samples and seeing which is bright, which is dim, this one is turned off. But for routine imaging, I always keep it on auto scale and best fit range. You can always bring your mouse here and you can see the number or the intensity here. If it is above 1000 units, that's okay signal. If it is below 1000, that means the signal is pretty weak. Okay. For now, I will keep this as 100 milliseconds. So I have some good intensity. If I bring my mouse here to the brightest spot, something like 20,000 units, which is good enough. Now, if I acquire the DIC image, if I change the focus, nothing new information I am getting, so it's useless. Okay? So I will turn off the Z with this guy. It's not required. Sometimes you would like to see the boundary of the cell and the tissue, then this will be useful. Other than that, it's not much use. And in this case, it's literally of no use. I cannot see anything useful here. So I cannot always go and turn it off. But for the sake of this session, I will keep it on. Now, going to the Z series, there are two options: acquire wavelength at each Z, or acquire Z for one wavelength at a time. First one is very useful when you are using standard imaging like SD for all of them, and the spinning disk is not going in and out. It can quickly switch between channels and then image very fast. But if it's changing the setup all the time, it will keep clicking and keep changing, and all of that will slow down the imaging. Now this will be very useful, especially in the live samples. When your sample is moving rapidly, you don't want to be acquiring all the Z stacks for one color and then go to the next one. By the time you have gotten here, everything has moved. So in that case, the first option will be useful. But because my sample is fixed, so I literally don't care. I can actually go to the second option, where acquire all the Z's in one color and then move to the next color and acquire all the Z's there. That way I save the energy of the microscope and the moving parts. Okay. Now here is where we can adjust the Z's. So there are two options. You can, if you know the thickness of the sample, you can go to the middle of the plane and then just put the range in which you want to image. Usually people don't use that. People like to use the set top and bottom. So I will go to, suppose this guy, and yeah, this is the issue I was talking about. I have to go to 405 first and then go to 488. I need to fix. Okay. Weird bug, I don't know what is happening here. Now I will go to the Z series. So suppose this is my top, and then I will go here to the bottom, somewhere here, and then you stop. So overall, recommended step size is 0.2 microns. At 0.2 microns, it is going to take about 72 steps. If you have enough time, you can acquire that. If you think that okay, this is going to take too much time, you can always change the step size. You can increase it to a little larger number so that you are not taking too many steps. But it depends on what you are trying to acquire. If you are, that is basically depending upon the Nyquist sampling. If you have a Z step of 0.4, the tiniest thing that you can resolve in that Z direction will be 0.8 microns, the double of this number basically. So the best that microscope can achieve is 0.4. So for now I will keep it 0.2. Okay. All the things are set up. Now all I have to do is to hit acquire. But before that, one quick thing is this binning here. I have talked about that in the video, but here you can control the resolution that you are accomplishing. Depending upon the pixel size and the magnification that you are using, binning size will determine the resolution. For routine imaging, 2x2 is good, but if you are looking for to resolve like tinier objects here, then you might like to make it bin 1 by 1. So then it blows up the image 4 times, but the signal will reduce 4 times. So accordingly you will have to decide what you want. Alright, so for now I'll keep it 2x2, and here it will give me an option of what do I want to keep after the imaging is done. For the acquired images I keep it on like that, and then just summary wise it is going to acquire all the images, and total size will be like 104 megabyte. And I will just say acquire, and as I hit that, so looks like something wrong happened. Let me continue this. So this is reality. This is what happens because we acquired this guy first, so it got messed up. The channels got messed up. So I will stop this and redesign the protocol a little bit. Maybe we'll move this one up, because if we keep SD-405 on, that helps a lot. So I will exchange these two. This is 500. And this one is 100. Let's see if this fixes the issue. And it only acquired 4 planes, so that means something is wrong. But it acquired everything. G series, oh, it changed. No, because 4.2, I don't know how it happened. But now it's done. Okay, it acquired this image first, then it goes here and it is going plane by plane. Like 72 images it will capture at whatever speed we put it. Now if you want to acquire the same image in the other microscope, each image will take about 3 seconds or 1 second or something like that. But here it is acquiring in milliseconds. So that is the beauty of this microscope, because it's doing a live image at a video rate basically. So that's the biggest power. So now it is going layer by layer here. Channel 1 is done, channel 2 is going on, then this one will go, and then we should be done. And it gives me a live idea of how well it is right now. And while it is doing that, let's go to the folder where it is stored. Today's training, and I will open Fiji or Image. Fiji can be downloaded free of cost from internet. I like it because it has got all the plugins required to open pretty much any kind of microscopic image from pretty much all the microscopes. Once the imaging is done, then the files will show up here in the folder. Automatically, I don't have to go and save each file one by one. The files it will produce will be TIFF files, and they will all be linked by this ND file. So while opening this, all we have to do is to drag and drop the ND file, and it will be able to open everything. And almost done. These are the files, and if I drag and drop, it will give me an option to do a hyperstack. I say OK. So there are 2 sets of images, the spinning disk images, and this is a bright field image. For now I will not open the bright field image, I will just open the spinning disk image, say OK. It's a big file, so it might take a little while. Let's see how big it is. It's 435 megabyte. And here are the different colors, 1, 2, 3, and you can go through the different G stacks. The colors that you saw here are fake colors. You can choose literally any color. All you have to do is go here and change, check the color whatever you want. So don't worry about the color that is here. You can make it any color. There are methods to do so. You can check the internet for doing that. But overall, that's the big picture of the imaging. But before we move forward, any questions with regards to anything?
No, already.